Hello, and welcome to this webinar. Today's guest speaker is Weimin Xu, co-founder and senior vice president of Epitomics, a member of the Abcam family. Weimin has played a key role in the growth of Epitomics. Currently, he oversees technology innovation, RabMAb production development, and business development at Epitomics. Before joining Epitomics, Weimin was a senior associate specialist at the Lung Biology Center at the University of California, San Francisco. This was where he pioneered rabbit monoclonal antibody technology by creating a new rabbit fusion partner, 240EW, and establishing a high-throughput system for rabbit hybridoma generation, which is the core technology of Epitomics. Weimin received his MS in cell biology from Xiamen University in China and was a research fellow at Zhejiang University, where he started mouse monoclonal antibody development. Following this, he held a visiting scientist position at Milan University in Italy, before moving to the Gladstone Institute of Cardiovascular Disease. After developing the RabMAb technology at the University of California, San Francisco, Weimin worked as a research scientist at the Biosm Corporation to continue RabMAb development and the discovery of several drug candidates. He is the author of over 20 scientific publications, co-inventor of several patents, and an advocate of RabMAb technology. Weimin received his MBA degree from San Francisco State University. Joining Weimin today will be Anina Hu, Senior Marketing Coordinator for the RabMAb product range. Anina studied and received her PhD at the Max Planck Institute and the University of Bremen, Germany. Anina joined Abcam in 2011 and is based in the Cambridge office within the UK. I will now hand over to Weimin, who will start this webinar.
Hello, everyone. Thank you, Lucy, for the nice introduction, and thank you to all for attending this RabMAb webinar. As Lucy mentioned, 17 years ago, I started to work on rapid monoclonal antibody technology at the University of California at San Francisco. At that time, I believe very few people knew this technology. And even a few years later, when I give a talk about the rapid monoclonal antibody in a big meeting, still many people didn't know this technology and always confused with rapid polyclonal antibodies. Now, after 17 years, I'm so glad to see this technology is widely known by many people, and there are thousands of RabMAb products in the market. Today, I'm going to share with you something about this new technology and its benefits. Hopefully, it will benefit your research. I'm going to cover 3 topics. Why rabbits? How this technology was developed. And the third, the benefits or advantage of this new type of antibody. And I will share with you a few examples. Actually, each topic deserves one whole webinar to cover. That's for today's talk. I can only go through each topic briefly and bring up the main points. So it may take a little bit longer time than normal webinar time. So I'll thank you in advance for bearing with me. Also, I have put additional information for each topic in my last slides if you want to know more details. Okay, there are 5 known platforms for people usually use to make antibodies. Mouse monoclonal antibody is the most common one, which takes more than 90% of market. Rat monoclonal antibody is kind of similar to mouse monoclonal antibody, but it's used as commonly as mouse monoclonal antibody. Antibody display technology is used PCR cloning molecular approach to generate the antibody, which I mainly see people use for therapeutic application. Chicken and gold or sheep polyclonal are used mainly for secondary antibody purpose. There are few published papers talking about the chicken monoclonal antibody and a few sheep monoclonal antibody made through hybridoma approach, but I rarely see them in the market. And I believe those are still at the research stage. Rapid monoclonal antibody has been used in more than 100 years. Actually, before most monoclonal antibody technology was developed, rapid polyclonal antibody were the main research reagent due to their quality and quantity. In last 90s, the emergence of rapid monoclonal antibody technology has changed the research landscape, which is my today's topic. It is well known that the rapid produce high affinity polyclonal antibodies, and most monoclonal antibody has good specificity, but overall the affinity is not that great. Rapid monoclonal antibodies technology, or RabMAb, thus combine the natural advantages of rapid immune system with the specificity and the consistency of a monoclonal antibody. And it has become a new and better antibody platform after most hybridoma technology platform. In the following presentation, I will walk through with you those scientific evidence and data to support this statement. And there are 18 different strains of rabbits. Actually, there are more. So I just show this 18. They all looks very cute. For making rapid polyclonal or monoclonal antibody, typically we use New Zealand whites. I will spend some time to talk about the rapid B-cell immunology, which is important for me to explain why rabbits. Although from people's experience, rabbits generally produce better quality antibodies to many antigens than rodents. The reasons are still not fully understood. Recent advancement of rapid immunology has provided us some answers. As you know, the antibody repertoire or B-cell development is divided into two stages. The primary antibody repertoire development happens before the animal encounters the foreign antigen, and it usually takes place in bone marrow through the VDG or VG arrangement. However, in rabbits, the B cells will continue to develop in appendix or other gut-associated lymphoid tissue, gout, very slow gene conversion to continue increase antibody repertoire diversification and the size of antibody library. Mouse, rat, or human do not have a gene conversion mechanism. It is unique to rabbit. Gene conversion is a new mechanism for antibody maturation. Not like hypermutation, it borrows upstream VH gene or pseudo gene to increase the diversity of antibody variation domain. For detailed information, you can look into my book chapter, which is listed in the last slide. In addition, rapid primary antibody repertoire continues 6 to 8 weeks after birth, while in mouse or rat, it stops after birth. All those contribute to a larger primary antibody repertoire with wider diversity in rabbits in comparison with the mouse immune system. With the unique feature of rapid immune system, here are 2 practical tips when you make a rapid antibody. Number 1, I will not suggest raising rabbits in bacteria-free animal facility, since intestinal microflora or bacteria in appendix are critical for the primary antibody repertoire development. Secondly, I will not suggest use rabbit less than 6 weeks out for making antibody, since as I said, before 6 weeks, the antibody repertoire is still at a developing stage in rabbits. The secondary antibody repertoire starts to develop after rabbit encountering the foreign antigens. Thus, B cell move from appendix to secondary lymphoid tissue, such as spleen or lymph nodes. Gene conversion or somatic hypermutation take place in the germinal center of those organs, which leads to antibody maturation for select high and high affinity antibody. As rabbit has long periods of affinity maturation. In addition, CD1 is the third lineage of antigen-present molecule other than MHC1 and MHC2. And the CD1 is just for presenting lipid and glycolipids. Scientists have found that the rabbit has more comprehensive CD1 family compared with mouse. In rabbit, there's 5 CD1 isotopes versus only 1 in mice. I think this probably explains, in people's experience, why rabbits make better quality antibody to those kind of difficult antigens such as lipid or glycolipid compared with mouse at the molecular level.